Afternoon, guys. So I'm hoping that you guys are actually watching this earlier in the day. I'm actually getting it posted up for you, which will be kind of nice to have it up and ready to go by the time 4 or 5 o'clock rolls around, which will be pretty nice there. So, all right. So we've been dealing with absolute value equations, and now we're going to kind of get into graphing them. Graphing them isn't going to be a huge part of what we're going to be doing, but you guys still do need to know how to graph them. And I can actually tell you that these are actually going to be similar to quadratic equations. Okay, so that'll be important to remember. So the absolute value form, the form that it's most convenient, I guess you could say, to have it in when you're graphing is y equals a times the absolute value of x minus h plus k. And when you have it in this form, then your vertex of the graph is going to be h and k. Okay, so that's important to remember. So when I look at a problem like this, I know that the formula is y equals a times x minus h plus k, where hk are the vertex. So that means the vertex of this problem, since there is no h and there is no k, will be the point 0, 0. Okay? Now, again, something you guys need to get comfortable doing is being able to determine where you need your x and y axis to be. Okay? So when I look at a problem like this, it is possible to have positive and negatives to an extent, depending on where your vertex is. So I'm just going to go ahead and for this problem, I'm just going to put it right in the middle, or pretty close anyways. Okay? So I've got my x and my y axis, and I've got my vertex at the point 0, 0. So I'm going to put a point at 0, 0. Okay? Now, again, these are kind of like parabolas in a way. As a matter of fact, they're the quadratic form for graphing is actually very, very similar to the absolute value form that we're going to be looking at right now. So one of the easiest ways to do this is just by doing a t-chart. So we're going to do a t-chart now. Very similar to quadratics, this is going to be what we call, I don't want to say what we call, but it's going to have an x value and a y value that are both going to end up being the same, just like a quadratic graph, basically. So the first one we did was 0, 0. Okay, so I'm just going to put that in the middle. Now, I know that, let's say I take negative 2. The absolute value of negative 2 is 2. And the absolute value of 2 is also 2. So I know at negative 2, 2 and at positive 2, 2, I'm going to have a number. And we can actually I'll do 2 more. So let's do negative 4 and let's do 4, which means this is going to be 4 and 4. So 1, 2, 3, 4, up 4 should put me right about here. And over 4, up 4 will put me right about here. And you should be able to actually see what this graph is going to look like, really. It's going to be a V. So instead of it being a U shape like a parabola, this is actually going to be a V shape, V-shaped graph. Okay, and now this is, so we've got 4, 4. We have 2, 2. This is 0, 0. This is negative 2 and 2. And this is negative 4 and 4. Okay? Now, this is going to be what we call the parent function, because this is actually what the functions start with. Everything we do, every one of the graphs that we do will be based off from this right here. Okay, they will be variations of what we do here. We could squish the graph and make it wider. We could translate the graph so we could move it to different spots, it's all going to be based off of this right here. Okay? So now let's go ahead and let's look at the absolute value of y equals x plus 2 minus 4. Okay? So again, we're going to use our x and our y axis. I'm going to go ahead and set up our x and our y axis. So about right here. And we're just going to put it in the middle again. Okay, and now for this one, we should recognize that, again, the function is y minus a, y equals a times, that's absolute value of x minus h plus k. So let's start by finding h and k. Okay, and that is going to equal, this is x minus h. Since this is plus 2, I'd have to write it as minus negative 2. So this is negative 2, comma, and instead of being plus 4, this would be minus 4. Okay, so my vertex is at negative 2, negative 4. 1, 2, 3, 4. So this is where my vertex is. Okay, now, my parent graph, okay, we did negative 4, we did negative 2, 0, 2, and 4. And this was 4, 2, 0, 2, 4. Okay, now let's look at our new one. Okay, there's going to be an actual pattern here that you should be able to recognize. Okay, so now my vertex is at negative 2 and negative 4. Well, right here, okay, the negative 2 is in the spot of the x, and I happen to subtract 2 from 0. So now, if we look at it this way, if I subtract 2 more to get the negative 2, okay, so we took negative 2, we're subtracting this negative 2, my value should be 2 plus negative 4, which would be negative 2. And if we plug it in here, we should be able to get that same value. So let's check it. Y equals the absolute value of negative 4 plus 2 minus 4. This is negative 4 plus 2 is negative 2 minus 4. The absolute value of negative 2 is 2 minus 4, which is negative 2. And that's what we got right here. So if you noticed, what I did was I took these same values right here, and I just added negative 2 to the x and added negative 4 to the y. So if I add negative 2 to the negative 4, I'll get negative 6. And if I have negative 4 to the 4, I'm going to get 0. Okay? And we can follow that same pattern all the way down. So now, so we did the first three. So 2 plus negative 2 is 0. And 4 plus negative 2 is going to be 2. 2 plus negative 4 will be negative 2. And 4 plus negative 4 will be 0. Okay? And so let's go ahead and graph these points. So we graphed negative 2, negative 4. So now I'm going to go negative 4. So that was 2, 3, 4. Down 2, 1, 2. And I'm going to go to negative 6 and 0, which will put me right here. And now I'm going to go 0, negative 2, and 2 and 0. And you guys notice that I now have a very similar graph to what I had originally. It's just actually shifted down 2, and it's shifted down 4, and it's shifted to the left 2. And here would be the equation of our graph. Okay, and again, there are this, okay, you notice that it's a shift because our original point was here, so it shifts over and down, and every point follows that same pattern. Okay, now you can just plug values in for x and get values for y. That would be perfectly fine. Or you can use the h and the k and and then there also is going to be a significance to the value of a as well, that will play a part in this as well. And actually, a will determine whether the graph is narrower or whether the graph is wider as well. So if you guys have any questions about this, make sure, I've had some people say they're forgetting the questions that they had when they watched the notes. So my suggestion is to write down the questions that you have that come up during the notes on a sheet of paper, on your notes even, and then just ask me tomorrow when you're in class, when I ask if there's any questions that you have. Go ahead and ask me at that point whatever questions you have. Okay? I trust you'll have a great night tonight and come prepared to work tomorrow.